So, Friday, we started of the periodic table dictates some of the properties of the elements in the periodic table. Yes? All right, so what we said, guys, is the periods or the rows going across tell me how many energy levels I have. So if it was in period 2, it has 2 energy levels. Period 3, 3 energy levels. So to summarize that, periods, rows, indicate the number of energy levels in an atom. All right, so and that doesn't vary. Okay, that's pretty much set in stone. If I have a neon atom, it has 2 energy levels because it's in period 2. Okay, so today what we're going to be talking about is one additional property that you can tell from the periodic table, and it has to do with the groups. Okay, so the groups, which are the columns, are going to indicate the number of valence electrons, and that's the end of the sentence. I didn't say it like that. Valence electrons. Give me just a second. Sorry about that, guys. Thank you. Okay, so y'all didn't ask the question I was expecting, and the question should be, what's a valence electron? Okay, so a valence electron, guys, is an electron in the highest energy level. Okay, so when I mean the highest energy level, if an atom has 3 energy levels, then the valence electrons are in energy level 3. Okay, so the valence electrons of oxygen would be in which energy level? 2, because oxygen has 2, so it'd be in the highest one. The valence electrons for krypton would be in which energy level? 4, because it has 4. Okay, so the valence electrons are the highest energy electrons in the atom. Okay, they also happen to be the electrons that if you're conducting electricity, these are the electrons that conduct the electricity. Okay, if there's bonding going on, these are the electrons that are participating in the bonding. So these are kind of the most active electrons. Okay, so the groups indicate the number of valence electrons. Okay, so here's how it goes. Okay, and I know that's let me get whatever. Yeah, y'all can see that and see the one up there. Groups 1 and 2. Okay, so I mean all the elements in this row would be group 1, column, and all the elements in this one would be group 2. Okay, group 1 has 1 valence electron. Group 2 has 2 valence electrons. Okay, so so anything in group 1 has 1 valence electron. I'm sorry, I'm We had a lot of difficulty with this in previous periods. Okay, so potassium, since it's in group 1, I know potassium has 1 valence electron. How many energy levels does it have? 4. Okay, so I know it's going to have 2, 8, 8, 1. That last number, since it's a 1 here, that last number is always going to be a 1. So when I'm writing out my electron configuration, for every single one in this row, the last number is always a 1. For every single number in this row, the last number is always a 2. The last number in the electron configuration. So, for example, for potassium here, since it's in the 4th period, that's 4 energy levels. So it has 1, 2, 3, 4 energy levels. Okay, this one's filled with 2, but since it's in group 1, I know this number is always going to be a 1. This one, the max it can hold is 8. Okay, so that leaves 8 over. Because potassium has 19. So 2 plus 8 is 10, plus 8 is 18, plus 1 is 19. So that's how I get that 8 there. And so on Friday I was kind of mysterious about how I got that 8. Okay, that's how we get it.
So why are you showing us this way?
Which way?
This way.
What do you mean? Instead of the way I showed you Friday? Because the way I showed you Friday won't indicate the number of valence electrons. And this is so much easier. This is way easier. Okay, so for this, you just go by the group number, 1 and 2. For this middle, kind of the low section here, it's really unpredictable. Okay, you can't really go by the numbers up here. And the groups don't really have the same. So this one we're going to kind of omit. Okay, but when we get over to this one, okay, the number of valence electrons is just the group number minus 10. Okay, so group 13 will have 3. Group 14 has 4. Group 15 has 5. Okay, so if I'm counting across, I have 1, 2, 3, 4, 5, 6, 7, 8. Make sense? So we skip the low section, and it's just 1, 2, 3, 4, 5, 6, 7, 8. That tells me the number of valence electrons, or the number of electrons in the outermost energy level. But no. Okay, let's put that into words. Oh man, I wrote on there. I didn't mean to do that. Whatever. All right, so groups 1 and 2. Have 1 and 2 valence electrons respectively. Yeah, about to say, what does respectively mean, guys? That means 1 has 1 and 2 has 2. So if I said John and Sarah are a boy and a girl, then respectively, then that would mean John's a boy and Sarah's a girl. Or John, Sam, and Mike have a 91, 85, and 92 respectively. So John has... Yeah, just they go in order. Okay, so that's first rule. Groups 1 and 2 have 1 and 2 valence electrons respectively. And then groups 13 through 18 have 3 through 8 valence electrons respectively. Okay? Super simple, right? Alright, so how many valence electrons does oxygen have? 6. Has 6 valence electrons. How many energy levels?
2.
2. How many valence electrons does aluminum have? 3. How many energy levels? 3. How many valence electrons does magnesium have?
Wait a minute.
2. How many energy levels? 3.
So the top number is
The top number is the valence electrons, and the side number is the energy levels.
You bring it back.
Bring it back where?
The top number stands for the electrons, right?
Valence electrons.
So, what is 13?
You don't use 13, you just use 3.
So you don't use the number in front of it?
You don't use the number in front of it, yeah.
So, for example, neon would be 8.
Neon's 8, yeah.
I got you.
Okay.
It's 8?
Alright. Making sense, guys?
You said the top number is the valence electron.
Top number is the valence electrons.
So like on the test, you're gonna have to know which one.
Mm-hmm.
What's the side?
Is the energy levels. How many energy levels there are?
So, for nickel would be 0.
Nickel?
Because it's 10. 28.
No, maybe the ones in the middle don't work.
Yeah, you said that.
Yeah, ones in the middle don't work.
I got you.
Yeah. Energy levels is this way, valence electrons is that way. Alright, let me give you all a few to practice. And there's a little flashback involved here. Let's say I have chlorine 36. I want you to give me the number of protons, the number of neutrons, the electrons, the energy levels, and the valence electrons. I know y'all. My other classes haven't remembered this either.
You bring it down some?
Yeah, I'm sorry. Alright guys, try those 3. Super easy. EL's energy level.
Which one do we change? What does that do, niggas? It was the
It's either the neutrons or the electrons. Depends on which side it's on.
when it's minus, you add this.
This is the atomic number. So for chlorine, the proton is always the blue number. It never changes. Always blue. Huh? That's the new red number.
Did you say neutron?
So take the number, subtract it, and use that as the red number.
I actually said you know. You find it.
But for the valence electrons, it's going to be 7, not 7. Yeah, remember it's 1, 2, 3, 4, 5, 6, 7, 8. Yes.
Hold it. You gotta push it. Hold it.
This is right. One thing, the energy level is not right. Okay, so chlorine, it's in the third row. So the energy level's 3. 1, 2, 3. Third row from the top. Yeah, from the very top is 3. You have to start from here.
You finna break it. Huh? Electron level.
It's the first time I got 3.
You said period. Don't give up. Find yourself. Find answers. That's talking to me.
So energy level, that'll be, that's just going to be that's EL. Okay. It is number of, yeah, the room. It is number of outer electrons.
What's your heat?
Okay, 870. So they're related to the group. Or what? Chlorine.
Homie. Yeah.
So that changed the number of electrons.
I'm wrong.
That's gonna, if it's 2 negative, that means it has 2 more electrons. That has a negative 2 charge. Electrons doesn't have.
Yeah.
So,
Protons
come from the blue.
35. You don't round it.
Oh,
You know, tell me.
No.
When you chlorine, you got the 36, but you're not supposed to round it.
Yeah. That's nice about it. That's what you expect, so. That changes the number of electrons. So you change, you add the 2 to the electrons. The electrons, you start with the protons. So for nitrogen, you have 7 protons. Plus 2. Nitrogen. Oh, you already got the, yeah.
Do you look at what
Which one?
like, do you look at 30 or 40?
We're getting 30 for magnesium. Just look at the room. You can't place one. Here you change the number of neutrons, here you change the number of electrons, and then the charge changes back. And we make that negative 5.
But the neutron can't be you weren't sure.
All right, guys. Let's walk through these. For chlorine, okay, chlorine up here is number 17, so it's 17 protons. That number never changes, guys. That's the easiest one. Don't get that one wrong. Okay, I mean that's on the test. It's multiple choice, so that'll be an easy one. Okay, so chlorine, that blue number 17. The neutrons, this number minus 17. Electrons, since it's not an ion, same thing as the protons. For the energy level, chlorine is in a row 3, so it's 3. And then for the valence electron, it's in group 17, and so it should be 7. Yeah. For nitrogen, it's number 7. Since it doesn't have a number over here, I use the number up there, 14 minus 7. For the electron, since it has a negative 2 charge, then this is going to be 2 more than that, so 9. For the energy levels of nitrogen, it's 2. And for the valence electron, it's going to be 5. Okay, for magnesium, we're going to end up with 12, 12, 12. 3, 2. Alright, I want to make one comment about the valence electrons, guys. There's one exception to the rule that we talked about, other than the ones in the middle. It's helium. Okay, helium cannot, you see it's in group 18? It can't have 8 valence electrons because it doesn't have 8 electrons. It only has 2 electrons. So it has 2 valence electrons. Okay, so helium is a little exception to that. Okay, so make sure you're conscious of that. Yes, VE would be 2 on helium. Yeah. Okay, we good? Your homework will have a little extra practice on these. Okay.